Welcome students. In last video we studied about the difference between addition polymerization and condensation polymerization. Today we are going to study in detail what is the addition polymerization. So let's begin addition polymerization. Here I am writing this question in three ways. First, addition polymerization with mechanism. Second, chain growth polymerization. Yes student, addition polymerization is also known as chain growth polymerization. And the third, that is a free radical mechanism with example. So in exam, this question may be asked in three ways. One, addition polymerization with mechanism. Second, chain growth polymerization. And third, free radical mechanism with example. So first of all, in addition polymerization, monomers which are used are either alkenes or alkynes. Yes, monomers in addition polymerization used are unsaturated. They are alkenes or alkynes. Along with monomer, one important component of this reaction is a catalyst. This catalyst is also known as free radical generating initiator. Yes, this catalyst is also known as a free radical generating initiator. In this free radical generating initiator, that means the catalyst is used like benzoyl peroxide, acetyl peroxide, or tertiary butyl peroxide are generally used. So the two conditions, monomers are maybe alkenes or alkynes, and the second thing used, that is a catalyst, which is also known as a free radical generating initiator. It can be a benzoyl peroxide, acetyl peroxide, and tert butyl peroxide. So let's first of all study the structure of catalyst. Here we are taking benzoyl peroxide catalyst. Now the structure of benzoyl peroxide catalyst: C6H5, C double bond O, 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 C double bond O, C6H5. Students, you are aware that here the oxygen having oxidation number -1, and this form is known as a peroxide. So we can use a benzoyl peroxide as a catalyst in addition polymerization or chain growth polymerization. Now let's move on to theory. So here, to understand this theory, we are going to take example of formation of polythene from ethene. Polythene from ethene. So this reaction is divided into three steps. First step is chain initiating step. Second step is chain propagating step. And third one is chain terminating step. So the formation of polythene from ethene takes place via 3 steps. One is a chain initiating step, second is a chain propagating step, and third one is chain terminating step. So we are going to start with first step 1, chain initiating step. In this chain initiating step, first of all, we take monomer ethene with small amount of catalyst benzoyl peroxide and expose this mixture to heat or sunlight. So first step begins with the mixture of ethene and benzoyl peroxide exposed to heat or sunlight. In this step, first of all, our catalyst, that is a benzoyl peroxide, C6H5, C double bond O, 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 C double bond O, C6H5 is going to cleave by homolytic cleavage. Here both oxygen is connected by pair of electron. Because of the heat, the homolytic cleavage takes place and both oxygen receives their own electrons by breaking off or by cleavage of a bond. So that's how first C6H5, C double bond O, O, free radical forms. 2 molecules of free radical forms. Now again, this structure, we are very much aware, this structure can be converted into carbon dioxide structure. So in next step, here we obtain 2 molecules of C6H5 free radical and 2 molecules of carbon dioxide is released. So the process named free radical mechanism, it starts with the formation of phenyl free radical. Students, this is the chain initiating step. In this step, first of all, the formation of phenyl free radical takes place. Now this phenyl free radical is going to react with the monomer ethene. So let's begin the reaction. C6H5 phenyl free radical react with the monomer ethene CH2 double bond CH2. Now first of all, in monomer ethene, one is a sigma bond and other one is a pi bond. As you are aware, pi bond is a weak bond, and because of the presence of sunlight and or heat, that pi bond is going to break first. That means homolytic cleavage takes place of ethene monomer. Both carbon receives their electron through breaking of pi bond. This electron going to make a bond with phenyl free radical and they are going to produce C6H5 CH2 CH2 free radical. As we are aware that free radical react with free radical and forms the first free radical. Now this free radical formed here is going to react with another monomer of ethene. That step we will call it a chain propagating step. So here we are going to write step 2, chain propagating step. In this chain propagating step, the formed free radical react with another monomer of ethene. As you are aware, same here, one is a sigma bond and other one is a pi bond. So this pi bond is going to break, this carbon going to receive their own electron. So by receiving this electron, they react with free radical and increase the chain length. Yes. The chain length increases. That means the chain length of the phenyl free radical increases. Thus, how this free radical, long free radical, react with n molecules of ethene, and they are going to produce a long chain of free radical in which that CH2 is going to become a repeating unit and long chain free radical obtained. Okay, so I hope till now you are aware that how long chain free radical we obtain. So students, we can say that this reaction takes place in number of molecules. So there is a possibility that we can obtain a numbers of long chain free radical here, and this number of long chain radical can be react with each other. By reacting them with together, we are going to conclude our third step. That means the third step is chain terminating step. So let's move on to third step, that is a chain terminating step. Chain terminating step. Before starting chain terminating step, I want to give you some hint that this chain terminating step can be possible in two ways. First, chain terminating via combination and chain terminating via disproportionation. Yes, the second one, chain terminating via disproportionation, this step is not included in our NCERT textbook, but the terminating step can be occur via two steps, via two procedures. It can be takes place via combination or it can be possible via disproportionation. So first we are going to take a step of a combination that is given in our textbook. So as we said that in second step we obtain a long chain of free radical. The number of long chain of free radical. That means suppose we have two molecules of long chain of free radical. That means C6H5 CH2 CH2 n times CH2 CH2 plus CH2, 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 CH2 n times C6H5. This both long free chain of free radical going to make a bond and they are going to combine with each other. That's why we can say this is a chain terminating via combination. So we can predict here that the product will be C6H5, CH2, CH2 n times CH2, CH2. The new bond formed here that via the combination CH2, 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 CH2 n times and at the terminating point C6H5. So here the via combination reaction of chain terminating step we obtain a long chain of polymer, that is a polythene. So that is a simple process via combination. But the second, which is not included in our textbook, students, always remember here chain terminating via disproportionation. So how this reaction going to take place? Let's study chain terminating via disproportionation. Chain terminating via disproportionation. So first of all you must be aware what is a disproportionation. Disproportionation, this word you have studied in a redox reactions. It is an example of redox. So disproportionation in disproportionation reaction, first of all we have a long chain of free radical C6H5, CH2, CH2 n times CH2, CH2. So I can write the second last CH2 like this term. C6H5, CH2, CH2 n times CH, CH2. So because of the sunlight is present here, we are exposing this mixture to the heat. That's why the homolytic cleavage takes place and this CH2 releases hydrogen in the form of hydrogen free radical. So here we obtain C6H5, CH2, CH2 n times. Now focus here, CH double bond CH2. So what we obtain here? Here we obtain alkene and hydrogen free radical is released. So now the question, where we are going to use this hydrogen free radical? So we have a numbers of long free radicals. In another long free radical C6H5, CH2, CH2 n times CH2, CH2 phenyl free radical. So students, in this disproportionation the hydrogen is released in the form of hydrogen free radical. Now this hydrogen free radical, here we have a possibility this hydrogen free radical can be react with the long chain free radical. Yes, as we said earlier that free radical always combine with the free radical. So this hydrogen free radical, if combined with the long chain of free radical, it is going to produce C6H5 CH2 CH2 n times as CH2. Now that CH2 containing free radical combined with the hydrogen free radical, this is going to create one bond. So this terminal point is going to convert into CH3. So our obtained product is C6H5 CH2 CH2 n times CH2 CH3. So the one obtained product is an alkene and the second obtained product is alkane. Yes students, all the bonds are single bond and this form is a alkane form. Now question may be arise in your mind. Sir, we are studying the addition reaction, preparation of polythene from ethene. Here the both terminating points are the different. So how can we say that this is a polythene? So I want to say that we have a n times of CH2 single bond CH2. That means we have a innumerable ethene monomer is present in this structure. But in this structure only the terminating, that means the head and the tail, that is just only different. That means if we have a crores of CH2 CH2 and in that mixture only one is a C6H5 and that the last one is a CH double bond CH2. So that is not going to affect our product because we have a n times of CH2 CH2. That's why this reaction is also known as a polymerization reaction. Okay students, so I think you must be aware what is a addition polymerization or what is a free radical mechanism or what is a chain growth polymerization. Once again we are going to repeat the whole process. First of all, monomers that are used, that is a unsaturated compounds, alkenes or alkynes. Catalyst, that is a benzoyl peroxide, it can be acetyl peroxide or it can be a tertiary butyl peroxide. So this process of polymerization takes place in a 3 step. One is a chain initiation step, second one is a chain propagating step and the third one is chain terminating step. First of all, in a chain initiating step, we have a mixture of ethene monomers and catalyst that is exposed to heat and they are going to produce the free radical. In chain propagating step, that free radical combined with the n numbers of monomer and the growth of chain increase. That is called the chain propagating step. And the last one is a chain terminating step. It takes place in a via 2 process. It can occur through a combination or it can occur through a disproportionation reaction. And that's how we obtain our product polythene from ethene. Okay, so I hope students you are aware how this reaction going to takes place. If you like our channel, then subscribe it. Thank you.